If all months are equally likely, that means that each month has a 1 in 12 chance of having a president's death in it. So our null hypothesis is that P1 equals P2 equals P3 equals all the way to P12, where each of these is for one of the months, and they're equal to 1/12. And the alternative is that they're not all equally likely. Now, in order to solve for this, we want to figure out the expected amount per month. So we need to know the total number in their sample, which if we add up this column, we're going to get 37. So our expected is going to be 37 times our 1/12. At alpha equals 0.05, can a psychologist conclude that the person's location is dependent on the number of years of college? So our null hypothesis is going to be that location is independent of years of college. And the alternative is that location and years of college are dependent. Now, in order to calculate the test statistic and p-value, we're going to use the assistance of technology. And since we have a two-way table, we want to use a matrix for this. So we're going to go to second and matrix. Now we need to edit a matrix. And we want to tell it how many rows and how many columns. We do not want to include the total. So we have 3 locations, urban, suburban, and rural. So we have 3 rows. And we have 3 different levels for the years of college, so we also have 3 columns. We'll hit enter, and it'll fill in the blanks that we can put in our numbers. So we'll say 15. It's going to go across the rows. So then 12, 8. Going to go to the next row, 8, 15, 9, 6, 8, and 7. Once I have my matrix filled in, I can go back to my stats area, go over to tests, and all the way down to the bottom again. And we see the option for chi-squared test. Now this option is going to allow me to test for independence and actually homogeneity when we get there. I've put my matrix in matrix A. If we needed to go find it though, because it wasn't in matrix A, I would hit second and then matrix. And I can choose wherever my matrix happens to be. I would highlight it and then hit enter, and it would bring me back. An expected matrix is where it's going to build the expected values for each one of the areas and years of college combined. So we don't need to do anything with it. It's just where it's going to store that matrix. So all we want to do is hit calculate. And now we have our chi-squared test statistic and our p-value. So my chi-squared value is 3.005 and my p-value is equal to 0.5569. If I compare that p-value to my alpha of 0.05, I am definitely greater than it. So we are going to fail to reject each not, which means that location and years of college are independent. My test for homogeneity is exactly the same as the test for independence. The only difference is what goes in the null and alternative hypothesis. In the null hypothesis, we're going to say that P1 equals P2 equals P3. We're not sure exactly what the proportion is, but we're saying they're all equal for each one of the error lengths. And the alternative is just going to say not all. Actually, I'm going to change it to at least one proportion is different. Not all of them have to be different, but at least one of them is. All right, and we're going to run it the same way we did the test for independence. So I'm going to put all those values in a matrix. I tend to just use matrix 1 or matrix A because then I don't have to shift it when I go to the test. And this time I only have 2 rows, one for yes and no, but I still have the 3 columns. And we're going to say 10, 7, and 4, 90, 93, and 96. I'm going to go back to stats and over to tests and go find my chi-squared test. As long as I keep using matrix A, it'll replace matrix B. I shouldn't have to change anything inside the test itself. So I'll just hit enter and I get a chi-squared value of 2.764 or 2.765 and a p-value of 0.251. If I compare it to my alpha of should be 0.05, I'm greater than it, so I'm going to fail to reject H naught. So there is insufficient evidence to reject the claim that all airlines have the same proportion of lost luggage. For an Anova test, we're going to run the test on all 3 sets of data. We can now compare more than one mean, and our null hypothesis is going to be however many means we happen to have. In this case, 3. The null is going to be that the first one's mean equals the second one's mean equals the third one's mean. And the alternative is going to be that at least one mean is different. And this has the same null and alternative every time. The only thing that has to change is that the null has to have the same amount of means for the amount of groups that you have. Now, this time, all I want to do is enter my data in a list. So we're going to take all those sets of data and go to Edit, and we're going to need 3 lists. So list 1 will be the medication, 10, 12, 9, 15, 13. List 2 will be for the exercise. We have 6, 8, 3, 0, and 2. And list 3 will be for diet, so 5, 9, 12, 8, and 4. Now they do not all have to have the same amount of samples in them either. Anova can be run on multiple sample sizes. But once I have my data entered, I'm going to go over to this testing area again, and the very last option is an Anova test. It's going to pop up with a parenthesis. All I want to do is tell it the list with commas in between. So list 1, comma, list 2, comma, list 3, and hit enter. It's going to give me a lot of great information, and this one, what I really want to pick out is the F-test statistic and the p-value, which are the first two numbers that it gives me. If I scroll down, it's going to continue to give me all the other information that we would get from an Anova table if we used a computer software program like StatCrunch. We're going to get it all, putting it out in a nice little table, but we do have it all and could build the table from the information that we get from the calculator. But what I'm interested in is the fact that the F-test statistic is 9.167 and the p-value is equal to 0.0038. If I compare that to my alpha of 0.05, I'm less than it, so we are going to reject the null hypothesis. So there is sufficient evidence to reject the claim that at least reject the claim that there is no difference among the means for the different treatments.